So let's write some code which would demonstrate an application of our knowledge. Just to save some space, I will get rid of this dummy use in my main function, and instead I will create an integer array, say of maybe 5 integers, and initialize them all to 0. That's how it would normally look like, right? So ARR is an array of 5 integers, all initialized to 0, because if any initializer elements are missing, the rest of the elements are initialized with 0. So this is similar to me saying 0, 0, 0, 0, and one more, 5 elements, right? So, but that can be simply abbreviated to this so that everyone understands that every single element of array of 5 integers is initialized with zeros. Let's instantly try to look at this in our memory. So we have this main function, right? What it does here is create this integer array of 5 integers initialized with 0. In computer memory, when we look in computer memory, our main function which has all of this executable code compiled for it, right? Of course, this goes into the text segment, so this is where the executable file, code is located. But the function before it runs allocates something we call a stack frame, which is basically a placeholder for local variables. Placeholder for local variables. And this array is also a local array automatically allocated inside main. Therefore, it's treated as 5 local variables. Each of them is an integer, right? So this the actual elements of the array are allocated in the stack frame, which belong to main function, right? So the main function, basically, when we compile this main function, its outcome is that we produce this the stack frame at runtime, which is given to the function, and of course there is some executable code which is placed elsewhere. This would be our text memory segment, and this will be our stack memory segment. So stack memory segment is the placeholder for stack frames of each associated with each function call, and each function call allocates space on the stack. It's called stack frame, and that stack frame hosts all local variables, right? So if I would have created another variable int x somewhere in the main function, x would be also allocated inside the stack frame that belongs to main at runtime. Okay, then I would like to initialize this array with some other values. What could I do? I could say initialize array, something like that, and pass this array as a function argument. So initialized array is a function which I would like to have and I would like to call, and initialize array, basically its name, and I would like to pass my array to that specific function. Okay, since we already have dummy.cpp as an example of the source file, I will perhaps use its content, move it to another side, right? And I could use initialize array as a function that takes some argument over here, and it has the body, right? And does something with this array. Perhaps its return type should be void because I don't know what it returns back. Just if I want to ignore the return value from this function, I'll just simply name it or give it a value void. Now the question is, what should be the parameter? Well, I can try something like this. I can try it this way. ARR was declared as an array of 5 elements. Copy, Control C, and paste, right? And paste it right here. And just say, oh, could I pass my array to this function, initialize array, in its initial form. Basically, what I'm trying to say that this function name initialize array should take an argument which is named ARR, right? And it's an array of 5 integers. That's how you normally vocalize it. Okay. Of course, in order for this to work, because initialize array is defined inside dummy.cpp, whereas the function call occurs inside main.cpp, both have to know about the function prototype. Because we discussed this earlier that to decouple function definitions from function calls and not require each program to define a function before it gets called, all we have to do is that we have to take the header of this function like this, with its name, the list of parameters, and the return type, which is void, Control-C, copy it, and place it in some header, right? Like this maybe, and just use the semicolon. So over here I could add some comments which would say global variables declarations, and here would be like function declarations or function prototypes, right? All this program needs, all this main function needs to know is the name of the function, the fact that it is a function because it has the parentheses in its prototype, the type of argument it wants, and whatever it returns. And we just use the semicolon, and we essentially, again, tell the linker that, well, you know what? Don't worry. Someplace the definition of this function will be found. Right now, we just want to be able to use its name and its parameter. Okay, so now I have, so let me save everything, and now I have this includes my header. Now, instead of just declaring a dummy variable, I also declare a function prototype which takes an array as a parameter. Now, let's do something about this, right? So this, notice that this is the header file. So the header file gets those variable declarations, gets function prototypes, but also we have a CPP file which is still named dummy because I still don't have any idea what the purpose all of this is, but it's just a demo, right? So the question is, inside this initialize, how many elements to initialize? Question mark. Now, your book talks about the fact that array loses its size when you pass it to a function, but I would like to go by example and show you what happens. As always, I go back to my, sketch which talks about the memory. So far we have been able to identify that function main, when it's compiled and when it's loaded for execution, when the execution happens here, so the CPU executes these instructions from function main, it will actually access the local variables, including our array, which will be placed inside the stack frame, which is essentially the placeholder for our local variables. Okay, so let's talk about this. Let me actually erase this and just do a cleaner drawing of this. So let's say that this is my main function stack frame, right? So this, I'll just simply say stack, right? So this is stack memory segment. We have 5 elements of this array right here. All of them are actually initialized with 0, 0, 0, 0, and 0. And then we call function. So this is stack frame given to main, a function, and then we call initialize array, right? And that's another function which obviously will get its own stack frame so that it can actually execute and do something meaningful. When you pass integers such as x and y to functions, their copies are, the way the arguments are passed to functions is that first, the copies of their values are copied to the stack. So if I had a function initialize array, which takes integer x and integer y, it should be actually the opposite, right? Integer y and integer x, something like that, just so that my arrows correspond to something. Then their values would be copied to the stack, and then the function would be invoked, and it would find the 2 integer parameters in its memory already initialized, because we actually took time to copy x and y and place it inside initialize array even before it was invoked. However, our situation is different. We pass the array. So we actually, what we do is that if you notice what I do during the function call, I pass ARR as function argument, but the actual type of function argument is an array of 5 integers. The name such as ARR stores the address of the first element of the array. And in C, unlike anything else, arrays are unique because instead of being passed by copying these 5 elements to the stack, which would be normally the case with normal variables, only the address of the array is placed on the stack before function is called, and obviously this is just an address of the first element of the array in memory. In other words, arrays are passed to functions indirectly by address. Okay? Arrays differ from regular variables in this type of interaction. When you want to have functions such as initialize array, which take array as an argument, what they get is only the address of the first element of the array. And I would like to obviously experiment with some of this code. So let's take a break.